Good morning everyone. Last time we have covered the quiz 1 and solutions as well. Now today we are going to discuss quiz 2. So the very first question is, which of the following is not a nucleophile? So first of all, you should know what is nucleophile. So we can say here nucleophile is a electron rich species, and what is nucleophilicity? It is a tendency to donate electron, okay? And we can say lone pair, negative charge, carbon double bond carbon, carbon triple bond carbon, and benzene. They are all act as a nucleophile because they have high electron density. So as you can see, we have a lone pair here, we have a lone pair, and here as well negative and lone pair both. So this is basically called as ambident nucleophile, means two centers for it has two center to donate its electron, negative as well as lone pair. So A, C and D are nucleophile, while if you look at the structure of SO3, three more electronegative element is bonded with the sulfur, so it is going to break this bond like this. So as you can see, we have a positive charge over sulfur. Now here we have a resonance as well. So positive charge means there is a deficiency, so it can grab the electrons. So that's why SO3 is behaving as electrophile. Clear? Now move to the next question, second question. And I have to delete this. You can pause the video and try yourself, okay? Second question is talking about find out the most stable free radical. I discussed this. Radical's stability depend on the resonance. If resonance is common, then give priority to the tertiary, then secondary, and then primary. Here we have a ring inside the cyclohexane, so which means there is an alternate double bond here like this, and CH2 have a radical. So now you can see radical is in alternate with the double bond, which means conjugation, so it can donate its radical to the double bond. So there is a resonance, and resonance is always the most stable form, okay? It provides more stability than tertiary and secondary. So here we can say A is the most stable form. Now the next is the question 3. So which of the following compound the hydroxyl group proton is most acidic? So look at here the acidic strength. Suppose you have any acid Ha1 and we are going to dissociate the HN, so it will become A1 minus. And second Ha2, if you are going to dissociate, it will become H plus plus A2 minus. So these A1 and A2 are the conjugate base. Now you have to check the stability of conjugate base, and I am saying suppose A1 negative is more stable than A2 negative. It means Ha1 is a stronger acid than Ha2. So simple thing is that is stable the conjugate base. Is stable the conjugate base is stronger the acid. And which hydrogen you can ionize? The hydrogen which is directly linked with fluorine, oxygen and nitrogen. These are highly acidic hydrogen. And how we can check the stability? The stability of anion depends on resonance as well as electron withdrawing group. If resonance is not there, then electron withdrawing you have to consider. So if you are going to remove all the protons from here, there is a negative on the oxygen. Now we have to check the stability of conjugate base. So as you can see, this is electron withdrawing. This is electron withdrawing as well. This one electron withdrawing. and this one also electron withdrawing. So this is a bit dipole induction. So here distance is an important factor. So whenever electron withdrawing group is connected very close to the negative charge, then it provides more stability to that anion. So as you can see, this oxygen negative is directly bonded with the fluorine at very close position. So this F minus is going to provide more stability to this anion. That's why D is the most stable conjugate base, which means D is the most acidic as well, most acidic. Clear? Why most acidic? Because its conjugate base is more stable. Now we can move to the next. So this is the page. Here now the next is question 4. Let me zoom this. Okay. So this question is talking about the most stable conformation of 2,3-dimethyl butane. So if you have a bit idea about butane's conformers, then I think you should know NT staggered is the most stable, then staggered, then partial eclipsed, and then fully eclipsed. NT staggered is something like that, where both methyl groups are opposite to each other at 180-degree angle. 180-degree angle, it means they have very less repulsion. So in that case, you have to observe which methyl are NT 180 to each other. So here, these two methyls are very close. Here suppose this methyl and this methyl are NT, and this methyl and this methyl are NT to each other. Make sense? So they are going to cancel their effect. So here the net repulsion is 0, and that's why the B is the most stable conformer. Clear? And you can see here the 3 methyls are very close, in fact 4. So this is the highly unstable one. So through this you can observe this one. You have to just check the repulsion. When the groups are at 180-degree angle, then they have the most stability. If they are very close, they have high repulsion, high amount of energy. Okay. Now we should try this one. Let me remove this. Question 5 is related to the naming, and this is quite simple. You have to select a parent chain and then start numbering from that end where the double bond get the lowest number. So suppose this is my compound, I should draw like this. So first of all, you have to select the longest carbon chain, and this is my parent chain. And now you have to start numbering from that end where the double bond get the lowest. So this is symmetrical. You have to start from here or here, and both are symmetrical positions. So you start from any position. Suppose 1, 2, 3, 4, 5, 6, 7 and 8. So here we have 8 carbon chain and oct 4 in here. Oct. So first of all, you have to write the name of branch, the substituent. So 4, 5 dimethyl, because both are same and both are 1 carbon branch, so methyl. And now we have 8 carbon chain in the parent, so oct, and then 4 ene, oct 4 ene. Okay, so this is 4, 5 dimethyl oct 4 ene, 4, 5 dimethyl oct 4 ene. Yeah, so A is right. Now try the next one. So this is a very important reactions of alkene, and I did a video on this HBO and OMDM. OMDM is called oxymercuration demercuration and HBO is called hydroboration oxidation. So this side is my OMDM, oxymercuration demercuration, and this one is HBO, hydroboration oxidation. So in OMDM I discussed the trick as well. M means Markovnikov. Okay, so Markovnikov is what? Negative part of the reagent will attack on that carbon which has less number of hydrogen. So if you look at this double bond, here we have no carbon at this position, and this is also more substituted one. So Markovnikov is also like nucleophile. The OH ion attack on the more substituted carbon or less hydrogen containing carbon. So OH attack over here. So the product of Markovnikovs will be this. Clear? And just opposite of here, HBO, the OH is going to attack here. So which option? So the left one is CH2OH, here you can see, and the right one is a tertiary alcohol, this one. You know, here C and D, they have both are correct if you are talking about the combination, but you have to select the left and right. So left is your primary alcohol here and this is tertiary. Okay, so this is from OMDM and this one from HBO, hydroboration oxidation. Clear? So this is question number 6. Now we have a question 7. So this question is, we have alcohol SOCl2 with pyridine, then Mg ether, and then we have epoxide. So look at here. The very first step is the chlorine is going to substitute the OH. So here we have Cl. In the next step, Mg is going to insert between this carbon chlorine bond. So it should be like this. This is Grignard and this is my nucleophile. And in the next step, we have epoxide. So the attack is what? SN2. Clear? So this is going to attack on this carbon. Suppose this is 1, this is 2. So this bond is going to break. Now look at the connectivity. This is my 1, this is 2, 2 has dimethyl, and this O minus becomes OH after protonation. And look at carbon number 1. One carbon is bonded to this, and this is bonded to a ring. Okay, like this. Clear? So here you can see oxygen. This is epoxide, no. This is OH, no. Look at this. This is CH2. Again a CH2, again a CH2. And then a carbon having OH and dimethyl. Clear? So the first step is SN2. Second step is Grignard, formation of Grignard, and third one is what? Again SN2 type, nucleophile attack over here and this bond is going to break. So the correct choice will be D. Now the next is aldol. And here the question is, which of the following will not undergo aldol condensation? So here we have a information. It is given by those carbonyl compound. It is given by those carbonyl compound or those aldehyde and ketone which have at least one alpha H. At least one alpha H must be present. Must be present. What is alpha H? Look at here. Suppose we have a carbonyl and here we have a carbon with 3 hydrogen and here we have a hydrogen. So carbonyl neighboring carbon is alpha. This is carbonyl and this neighboring is alpha, and there is a hydrogen, so we can say yes, it has 3 alpha H and it can give aldol condensation. Look at this one. This is carbonyl but there is no neighboring carbon, so it cannot give aldol. Look at this one. Carbonyl and this alpha has a hydrogen, so it can give aldol. And look at this one. This is alpha carbon but there is no hydrogen, so it cannot give aldol. Now it's quite simple. The carbonyl neighboring is alpha and here hydrogen, it can give neighboring alpha. This carbon has hydrogen, it can give alpha. This one, this is also benzene ring but this side no alpha H while this side has alpha H, so it can give. And now this is very important, D. And D is this one. There is no alpha hydrogen at this carbon, so it cannot. Clear? So the right choice will be D. Now move to 9. You can pause the video if you are going to write down the solution, okay? And please subscribe and share. My plan is to discuss the quiz regularly as well as some content videos. So please subscribe the channel and share with your friends if anyone looking for the DAT. Now the 9, here we have 2 questions. First of all, let me know what is the name of this reaction. And my options are aldol condensation, Wittig reaction, Claisen condensation, and there is a one more like Michael addition. So as you can see, whenever you have a phosphorus halide, the reaction is called as Wittig and the product is very easy. Look at here the trick. Suppose this is my carbonyl bond and here we have PPH3 double bond, PPH3 double bond CH2. So you have to remove this oxygen with PPH3 and attach double bond CH2 with this ring. So your product will be like this, double bond CH2. So here you have to do the same thing. You have to remove this oxygen with PPH3 and connect this CH2 with this ring. So it should be like this, double bond CH2. And I think it should be the right choice. Okay, quite simple. Suppose my question is like this. This is the question supposed to be. In place of this, we have this L, suppose phosphorus halide. So simple, you have to remove this oxygen with PPH3 and attach this entire thing with this ring. So your product will be what? It should be like this, double bond, and now look at this carbon. This is the carbon. Clear? This is called Wittig. Now move to the very last question, question 10. This is very good question, very good. Oh. Okay, we have only option C. Okay. So we are using LiLH4. First of all, you should know what is the key function of LiLH4. So LiLH4 is a strong reducing agent. It is a strong reducing agent. It can reduce ester into primary alcohol. It can reduce acid into primary alcohol. It can reduce aldehyde into primary alcohol. It can reduce ketone into secondary alcohol. Ketone into secondary alcohol. Okay. So this is my ester. This linkage is a ester linkage. If you look at this compound here oxygen, double bond O, and here double bond O. So this is my ester. So if this is ester, it means this carbon will become primary alcohol like this. CH2OH. Clear? And here OH as well. And your secondary alcohol, secondary will become, yes, your ketone, this is ketone. So ketone becomes secondary alcohol. So secondary, this is ketone remains same, no. Here we have oxygen with alcohol, no. Here the last one is absolutely wrong. Why? Because ester remain ester. And now you can see ketone is secondary alcohol and ester is a primary alcohol. Clear? And this is also alcohol. If you break this linkage like this from here, here. So this becomes primary alcohol and oxygen got a hydrogen, so OH. I think I should write here like this. Wait. So look at here, this entire group, this is ester, so it becomes primary alcohol, and this ketone becomes secondary alcohol, and here this carbon also be OH once you break this ester linkage. So as you can see, OH, OH, OH. Makes sense? So C is the right choice. So this is all about the quiz 2, and maybe in couple of days again we are going to do the quiz 3. So please share and subscribe. This is only the request from my side. Thank you so much.